All right, welcome to this section. We're going to take things a little bit to the next level now on the fundamentals and talk about load balancers, autoscaling groups, and EBS volumes. This is going to make us understand how to scale an application on AWS. I hope you're excited. Let's go.
Okay, so now we're going to learn about load balancing. So you may be asking, what is load balancing? Well, basically a load balancer is a server that will front your application and it will forward all the internet traffic to your instances of your applications downstream. Okay, so this is what it looks like. We have our EC2 instances and they have our application, and we have a load balancer a bit before that. Now, when the users connect, they don't connect directly to the EC2 instances. They will connect to the load balancer. So we have user 1 connecting, and the load balancer basically redirects that traffic to the EC2 instance. The EC2 instance comes back with a response to the load balancer, and the load balancer gives back the response to the user 1. Similarly, we can have a user 2 that will connect to another EC2 instance, and a user 3 that will connect to another EC2 instance. It's called a load balancer because, as you can see, user 1, 2, and 3 do not go to the same EC2 instance in the backend. Okay, the load is being balanced. So that's the whole idea behind a load balancer. So why would you use a load balancer? Well, you really want to spread the load across multiple downstream instances so you can scale your instances downstream, but still expose only a single point of access to your application. Similarly, if your downstream instances fail, we don't want our clients and our users to see that failure, right? We want the load balancer to still work. And so the load balancer will do health checks to our instances to make sure they're working fine. And if they're not working fine, it will redirect the traffic to the instances that are working. Also, the ELB, the load balancer, can provide something called SSL termination or HTTPS for your websites. That means that the termination and the encryption of the connection is between the client and the ELB, and then the ELB, or Elastic Load Balancer, goes and talks directly to your instances in HTTP traffic. It can also enforce stickiness with cookies, so that means that the user basically will talk to the same instance over time. And there is also a concept of high availability across zones. That means that your load balancer can run across many zones, and so do your instances, and that basically allows your application to be highly available in case an availability zone just fails. Finally, the last benefit is to be able to separate public traffic from private traffic. So don't worry, all these concepts we're going to do a deep dive on right now. So why would you use one? There is basically an EC2 load balancer called ELB, and it's a managed load balancer. And AWS will guarantee that it will be working. AWS guarantees that they will do upgrades, maintenance, and will maintain high availability. And AWS will provide a few configuration knobs for us to tune things up. And these are really, really nice because everything is managed from the UI. Overall, even though it costs less to set up your own balancer, it will be a lot more effort on your end, and in the end, the total cost of ownership will be much higher. So it's very, very common to use the ELB from Amazon. Finally, it is integrated with so many AWS offerings and services for monitoring, for compute. So there are different types of load balancer in AWS, and that can be confusing. There are 3 kinds of load balancers. There is the classic load balancer, or V1, or old generation. And this was created in 2009. So this is quite old. And then recently, there was something called an application load balancer, which is V2, new generation, which is 2016. And we had a network load balancer, V2, also new generation, 2017. And overall, it is now recommended by Amazon to use the newer /V2 load balancer as they provide more features. So we'll see how the features relate to one another. But basically, the application load balancer and the network load balancer is what is going to be asked mainly at the exam. Although it's still important for you to know how a classic load balancer works. Overall, we can set up thanks to your load balancer an internal load balancer or an external load balancer depending on whether or not your application to be exposed externally or internally. So let's first talk about health checks. Health checks are really crucial for load balancers because they really allow you to redirect the traffic to instances that are healthy. They will basically enable to know which available instances are to reply to request. And basically the health check is super easy. You just give it a port and a route. For example, /health is very common. And if the instance says, yeah, I'm okay, 200, then the instance is healthy. Otherwise, if it's not 200, then the instance will be unhealthy. So here's what it looks like. We have our load balancer and we have our EC2 instances in the backend. and it will do a health check on port whatever you want, really. So 4567, but it could be port 80 or whatever you want. And it will ask for the root/health. And that's you who set up these things. If the EC2 instance says okay, then it's deemed healthy. If it's not okay, it's not healthy, and the load balancer will stop sending traffic to that instance. So application load balancers are V2, and they're called layer 7. Layer 7 because they allow you to work at the HTTP level. So the application load balancers allow you to handle multiple HTTP applications across machines. And so we're going to group these applications in target groups. In the next slide, I have a diagram to show you. Also, we can load balance to multiple applications on the same machine, and that's containers. So that's a very common question at the exam. They will say, we need a load balancer, we need something to load balance across the same application running on the same machine. How do we do this? And the response is an application load balancer. Finally, you can load balance using the root in the URL, or you can load balance based on the host name in the URL. So they allow for greater flexibility. Overall, I think load balancers are a great fit for microservices and container-based application, for example, Docker and Amazon ECS, but also for Amazon EC2, as we'll see in this lecture. Finally, there is a port mapping feature that basically the load balancer can redirect to any dynamic port in the backend, and this is what allows the load balancer to basically redirect to the same instance on the application running on the same machine. In comparison, if you wanted to run 5 microservices before using the classic load balancer, you would need 5 classic load balancer, and that was very expensive and inefficient. Now we have an application load balancer. You can use one load balancer fronting 10 applications if you wanted to, and that works great. So as a diagram, how does that look like? Well, we have HTTP best traffic, and so we have our external application load balancer, V2, and basically there's going to be a target group. And maybe our first application is the user's application. So we have our target group, and we have EC2 instances, and we also define a health check to make sure that these instances are healthy. And so our load balancer will basically redirect the HTTP based on the root. So if a user comes and say, I want the root/user, then the load balancer says, okay, I'm going to redirect to that target group on the right-hand side and to the instances that are healthy. Additionally, we can set up a second target group, maybe for the search application. And we have the same concept. We have many EC2 instances, and we have health checks defined on them to make sure they're healthy or not. And if the user requests a /search root, well, the external application load balancer will basically redirect to the search target group. And so that's the idea. You can have as many target groups as you want as behind your ALB. And then what happens is that in each target group, you can have as many EC2 instances as you want, and you can have health checks checking the status of these instances. So what's good to know for ALB? Well, you can enable stickiness at the target group level. So that means that the same user always goes to the same instance. And basically the stickiness will be generated by the ALB. So it'll add a cookie at the ALB level, not the application. You have nothing to do in your application. ALB supports 3 things. It supports HTTP, HTTPS, and WebSockets protocol. And the application servers don't see the IP of the client directly. So that's a very, very common and popular question at the exam as well. Basically, the true IP of the client is inserted in one header called X_for header. And if you want to still get the port, you can get X_port and X_proto. So you may be asking, how does it look like? Well, basically, we have our client IP, 1, 2, 3, 4, 5, 6, 7, 8, and it talks to our ALB. And what happens is that the ALB does something called a connection termination. So it will establish a new connection to your EC2 instance. So your EC2 instance sees the private IP of your load balancer. It doesn't see the private IP of the client. And for your EC2 instance to see the IP of your client, so 1, 2, 3, 4, 5, 6, 7, 8, then it needs to look at the header X_for. And this is how you get it. And this is a very popular question at the exam. Now, if we look at network load balancers, they're layer 4, and so they're a bit lower level, and it's for TCP traffic. Okay, so before it was layer 7 HTTP traffic, now it's layer 4 TCP traffic. And network balancers are deemed to be super high performance, so this is how they're advertised, and they can handle millions of requests per second, and they support static and elastic IP. They have less latency, so 100 milliseconds versus maybe 400 milliseconds for ALB. Those are ballpark numbers. And they're most commonly used for extreme performance, and probably won't be the default load balancer you'll choose overall. But this is the exact same process as the application load balancer. And so if we look at the diagram, well, we get the exact same diagram as before, but now instead of HTTP traffic, we're talking about TCP traffic. And that's simple. the TCP network and traffic will be routed to different target groups. So that's about it. Network load balancer, just remember, it's higher performance. Now, good to know, the classic load balancers, as I said, are deprecated. Now you want to use the application load balancer for HTTP and HTTPS and WebSockets, and you want to use the network load balancer for TCP. The CLB and ALB, so classic load balancer and application load balancer, support SSL certificates and provide SSL termination. All load balancers will have a health check capability. The ALB can route based on the hostname and the path. The ALB is a great fit with ECS or Docker. Also, all these load balancers, classic load balancer, application load balancer, and network load balancer, they have static host names. That means that basically we get a URL, as we'll see in the hands-on in the next lecture, we'll get a URL, and that will be the rest of the time the URL that our application will use. We should not resolve that URL and use the underlying IP. That is also a very popular question. Load balancers can scale, but not instantaneously. So basically, if you expect a massive load, like, a lot of load and it's expected for you, you should contact AWS for them to warm up your load balancer so that they scale with you. NLB, as opposed to ALB and CLB, they see directly the client IP on the application side, so there is no X forwarded for proto header before, but that's just for network load balancers. And then you should know that 4xx type of error are client-induced errors, and 5xx type of errors are application-induced errors. If you get a 503, that means that your ELB has no more capacity or no registered targets. And if the load balancer cannot connect to your application, then you should check your security group. So I'm aware that was a very heavy lecture and lots of knowledge right here. Don't worry, we're going to go into a hands-on lab in the next lecture to practice this. But just remember, we have 3 types of load balancer. One is deprecated, and the most common ones you're going to see at the exam is going to be the ALB, application load balancer. Don't forget about stickiness, don't forget about health checks and target groups. Okay, hope that was helpful. I will see you in the next lecture. In this hands-on, we're going to create a load balancer. So right now, to access our machine and our little websites, we have to go straight to the public IP of the machine, and then we get this hello world. That's a little bit more complicated, and we'd like to have a load balancer in front of it. So to do this, I scroll down on the left menu and click on load balancer. Here we can create a load balancer, and we get granted with the type of load balancer we want. So as you remember from the previous lecture, we have the classic load balancer, but that's previous generation, and that's deprecated, and it's gray. And then we have application load balancer for HTTP and HTTPS, and we have network load balancer for high performance. As you can guess, we have an HTTP application, and we don't need high performance, so we'll just create the one on the left-hand side, the application load balancer. Once you create it, you need to name it, so we'll call it web app application ALB, so web app ALB, and then the scheme is going to be internet facing because we want it to be public, but if you want it to be private, it'll be internal. The IP address type is IPv4, and then the listener is basically a list of protocols and ports that our ALB will listen on. We want to access it through the port 80 on HTTP. Here we can set how many availability zones to enable for our load balancer. So as I told you, it can be highly available. So in this case, I'm going to select all the availability zones. Next, I will configure the security groups. And basically, to do this, I get to create a new security group. And we're going to call it my first load balancer. And we'll say first ALB in the tutorial. So here we are going to accept basically any connection on TCP protocol port 80, so that's HTTP, and then the from anywhere, so the custom like this. This looks good. And then exactly configure routing. And so we say, okay, this ALB now is accessible, but what does it route to? What is the target group? And in our case, we have to create a new target group, and we'll call it my Apache target group. And it turns out that also we're going to redirect on port HTTP port 80. That's because our instance right here is accessible from port 80 on HTTP. And the target type is an instance. Now the health check, currently we don't have a /health root, but we have HTTP and path /. So that means that the health check will check whether or not this page is working. So the health check is correct. And here you can definitely customize the health check if you wanted to say, okay, To be healthy, you need to pass the health checks 5 times in a row. To be unhealthy, you need to not pass it 2 times in a row. Here's how often you run the health checks, what is the success code, etc., etc. So you get a lot of customization possible. Next, to register targets. As you can see, we need to register targets, and currently we have no registered targets. So for this, we can look at the available targets, and in the bottom we have my second instance that we created from before. And it turns out that we can add it to registered. And here it is, it's been added in the top panel. So next we're good, we click on review. And after this long setup, we have created our load balancer. So I'll click on create, and it goes through creating the security group, then authorizing the security group, creating the load balancer, etc., etc. I click on it, and load balancer can take a while to provision, so the state is going to remain provisioning for a little bit, so I'll just wait until it's provisioned. Okay, so my application load balancer is now provisioned. As you can see, the state is active. So we need to make sure everything works. And to make sure everything works, I could go straight to the DNS and see if that works. So we'll go and copy the DNS here. And yes, we get the hello world. So that's a bit magical though, so let's see what happens behind this. So the ELB was created, and we get out of it a DNS name. Now that DNS name is what I will use consistently for my application. That's a full URL, and it's never going to change no matter what I do with my instances in the backend. Now we can see it's internet facing, so I'll be able to access it from the web. And it's an application type load balancer. It's in 3 AZ, okay? The state is active, and everything looks great. Next, what I have to do is go to listeners, and as we can see, it is listening on port 80, okay? And as we can see, the default rule is to forward it to our target group. So we can add and edit rules here if you wanted to, add more target groups, but right now it says if you go to port 80, then you're going to forward it to the target group. So we click on the target group, and as you can see on the left-hand side, the little panel changed from load balancers to target group. And as we can see, our target group right here is on port 80, and it's attached to the load balancer we have from before. And as we can see, the targets on the second tab is our registered target. It's in AZ3C, and the status is healthy. So that means that the instance passed the security checks and the health checks, such as now it's available to be reached by the target group, and it's a healthy instance, so my load balancer is going to redirect me directly to this instance, which is pretty nice. We can look at the health check and look at the settings. We can also edit them if we wanted to, but overall, this works great. So this is why basically when we happen to hit that URL right here, it's going to talk to the load balancer, and then the load balancer will go ahead and talk to our instance that is only healthy. So if I refresh this page many times, as you can see now, basically we can access the only same instance we have registered. So now we have a problem, right? We can access our instance directly using the IP or using the load balancer. And so I want to show you a little trick with security groups, such as you only allow the load balancer to access your EC2 instance and not anything else. And this is, if you remember, the fact that security groups can reference security groups. So if we look at it, in this security groups panel, we have the first load balancer and we have the first security group right here. And what we want to do is to allow inbound traffic of my first security group only coming from the load balancer. And so we click on my first security group in the inbound rule, and we're going to edit them. And now we're going to say that the HTTP traffic on port 80 can only come from custom, and then we'll say SG, and automatically we get a suggestion to say, okay, we can use the load balancer. And so as we can see, this rule now says you only allow on port 80 coming from the load balancer. And I'll say in the description, only from the LB, and save this. So what this will do is that if we refresh this page, everything should work. So we are still able to access the website. But now if I refresh this one page, right here, as you can see, it's still connecting and it's timing out. So now we're not able to access our EC2 instances directly using their IP because we blocked it. The only way to access the port 80 is to go through the load balancer. And that's a very secure setup because now we're guaranteed that only the load balancer can talk to our EC2 instances on port 80. And it also demonstrates how to use basically a security group in another security group rule. You could play and stop, if you wanted, stop the instance and see if it becomes unhealthy or see what happens to the load balancer, etc., etc. But overall, this is how you go through the setup of a load balancer. Hope you enjoyed it, and I will see you in the next lecture. Now we're getting into the concept of auto-scaling groups. So in real life, basically your websites and applications will change and they will have different loads. So the more users, the more popular you're going to be and the more load you're going to have. So in the cloud, as we see, we can create and get rid of servers very quickly. And so there's one thing that an auto-scaling group does very well. It is to scale out. That means add EC2 instances to match an increased load, but also scale in, remove EC2 instances to match a decreased load. And then finally, we can ensure that the EC2 instances can only grow to a certain amount or decrease to a certain amount. And this is where we can define a minimum and a maximum number of machines running in an ASG. Finally, we can also have a super cool feature of the ASG, which is to automatically register new instances to a load balancer. So in the previous lecture, we did register instances manually, but obviously there's always some kind of automation we can do. So in AWS, what does it look like with the graph? Well, here is our beautiful auto-scaling group. It's a big arrow. And so the minimum size, for example, 1 here, is the number of EC2 instances you'll have for sure running into this auto-scaling group. The actual size or desired capacity parameter is the number of EC2 instances running at the previous moment in the current moment in your ASG. And then you have the maximum size, which is how many instances can be added for scale out if needed when the load goes up. And so that's super useful. What you need to know about is the minimum size, desired capacity, and maximum size parameters because they will come up very often. Also note that scale out means adding instances and scale in means removing instances. So now how does it look like with a load balancer? Well, here is our load balancer and web traffic goes straight through it. And we have our auto-scaling group in the bottom. And basically the load balancer will know directly how to connect to these ASG instances. So it will direct the traffic to these 3 instances. But if our auto-scaling group scales out, so if we add EC2 instances, then the load balancers will also register these targets, obviously perform health checks, and directly reach traffic back to them. So load balancer and auto-scaling groups really work hand in hand in AWS. So ASG, they have the following attributes. A launch configuration, and we'll be creating one in the next lecture during the hands-on. But the launch configuration has an AMI and an instance type, EC2 user data if you need it, EBS volumes, security groups, SSH key pair, and as you can see, well, this is quite common, quite the same things that what we've been creating from before when we launched an instance manually. Obviously, they're very, very close. You also set the minimum size, the maximum size, and the initial capacity, as well as the desired capacity. We can define the network and the subnets in which our ASG will be able to create instances, and we'll define load balancer information or target group information based on which load balancer we use. Finally, when we create an ASG, as we'll see, we'll be able to define scaling policies. So what will trigger a scale out or what will trigger a scale in. So we're getting to the auto-scaling part of auto-scaling, which is the alarms. So basically, it's possible to scale your auto-scaling groups based on the CloudWatch alarm. And we haven't seen yet what is CloudWatch, but as I said, Amazon is kind of a spaghetti ball, so don't worry, follow with me. So the CloudWatch alarm is going to be something that's going to monitor a few metrics. And when the alarm goes off, so when a metric goes up, it'll say, okay, you should scale out, you should add instances. And then when the alarm goes back down or there's another alarm saying it's too low, then we can scale in. So basically the ASG will scale based on the alarms. And the alarms can be anything you want to monitor, such as like the average CPU. And the metrics are computed as an average overall, okay? It doesn't look at the minimum or the maximum, it looks at the average of these metrics. Based on the alarm, basically we can create scale out policies and scale in policies, as I said. So there are rules and there are new rules for auto-scaling. We'll be seeing them in the hands-on, but now you can basically say, okay, I want to have a target average CPU usage in my auto-scaling group, and basically it will scale in and scale out based on your load to meet that target CPU usage. You can also have a rule based on the number of requests on the ELB per instance, the average network in, average network out. So really whatever you think the better scaling policy is for your application, you can use. These rules are easier to set up than the previous ones, and they can make more sense to reason about, saying, okay, I want to have 1,000 requests per instance from my ELB. That's easy to reason about. Or I want my CPU usage to be 40% on average. Now you can auto-scale also according to a custom metric. And basically, we can define a custom metric, say the number of connected users to our application. And to do this, we'll create that custom metric from our application. We'll send it to CloudWatch using the put metric API, and then we create a CloudWatch alarm to react to low or high values of that metric. And then these alarms will basically trigger the scaling policy for the ASG. So what you should know out of it is that the auto-scaling group isn't tied to the metrics AWS exposes. It's also be any metrics you want, and it can be a custom metric. So a small brain dump for ASG before we go into the hands-on. So the scaling policy can be CPU, network, or custom metrics, or even based on a schedule. You can use launch configuration, and if you want to update your ASG, you just provide a new launch configuration. If you attach an IAM role to the ASG, it will get assigned to the EC2 instances. We haven't seen yet what is an IAM role, but just know that they get transmitted from the ASG to the EC2 instance. And the ASG are free. You don't really pay for ASG, you only pay for the EC2 instances that are being spun up and spun down. So scale out and scale in. Okay, so ASG, overall, you should definitely use them because they don't cost anything. Having instances under an ASG means that if you accidentally, terminate an instance, the ASG will automatically create a new one or restart them. And so that's extra safety because now we know that if we need absolutely one instance running for our application and our EC2 instance, then the ASG will ensure that always one application is running. And then if a load balancer deems that an instance is unhealthy, so it says it does a few health checks and it turns out that the instance is unhealthy, then the auto-scaling group will automatically terminate the instance because it's marked unhealthy and then automatically replace them by creating new ones. So it's a really good way, it's a really good combination to work with a load balancer and ASG because together they can ensure that number one, your application meets the traffic and the load it's having. And number two, if anything becomes unhealthy, then the ASG takes care of replacing these instances. So that's pretty cool. I hope you're excited and I will see you in the next lecture for the hands-on. Okay, so now that we have a load balancer, we are going to create an auto-scaling group. So right below the load balancing menu, there is an auto-scaling group menu. So I click on it and then it says create auto-scaling group, which is exactly what we want. We'll create one and it says number one is to create a launch template and then we'll create an auto-scaling group. So as we've seen, first we need a launch template and the launch template will basically ask us for parameters and configuration options for our EC2 machines. So let's get started. First of all, just like before, it asks for a launch configuration and an AMI. We'll use the Amazon Linux 2 AMI. Click on select. And then in terms of what instances we want to launch, we will use T2 Micro. Then we will configure the instance details and we can create this launch configuration and we'll call it first launch config. Overall, we can set up a bunch of things such as an IAM role, monitoring, etc., etc. And the advanced details, always hidden, are user data. So because we want to set up our Apache web server automatically, just like before, but under an ASG, we need to put some user data here. And to do this, fairly easy, we're just going to go and copy that entire block. And you need to remember to copy the first line as well. So we'll copy this one line, and then we'll copy this entire block right here. And this will ensure that each machine that gets launched in our ASG will have HTTPD and Apache installed and will display our index.html file. So this looks good. Now click on add storage and we get the root volume just like before. We click on next. And now for the security group, we can select an existing security group and we can select my first security group. Why this one? Well, because we get SSH access just like before, but we also get access to port 80 and port 80 is only accessible by the load balancer, which is exactly what we want. We click on review and everything looks great. We click on create launch configuration and we have to attach an existing key pair and we'll select the one we created from before, EC2 tutorial. I tick the box because I still have that key pair and I create the launch configuration. So the step one is finished. We have created the launch config and now step two, we create the auto-scaling group. So the first auto-scaling group, call it first ASG for first auto-scaling group, and we'll start with one instance. Now we get to choose the network and the subnet. So we'll choose a default VPC that comes with your account. And because we want to launch instances in 3 different subnets to be highly available, we'll select the 3 different subnets right here. In the advanced details, you're able to also say that you want a load balancer. This is definitely what we want. We want to create receive traffic from one load balancer. And we won't select a classic load balancer because we haven't created one, but we have created an application load balancer. So we'll use target groups and we'll say use my Apache target group. So that means that any instance that gets created in this ASG will get registered into this target group. The health check type will choose ELB because we want the ELB to health check our applications. And the grace period is basically saying how long our application has to start before the health check goes bad. For us, 60 seconds should be enough. Everything looks good. We click on Next, Configure Scaling Policies. So when you create an auto-scaling group, you can define scaling policies, and we can keep this group at its initial size, or we can create a scaling policy and say, okay, I want between 1 and 3 instances, and I want the average CPU utilization to be equal to 40%, okay? And my instances need about 60 seconds to warm up after scaling. So this is the idea. Now, if we overload our web server, it will create instances up to 3 instances, that's the maximum. Otherwise, it will keep at the minimum being 1. So this is great. This is our scaling policy. And now we configure notifications. We don't need notifications. Tags, we don't need tags either. And then we review it, and everything looks great. So I create my auto-scaling group now. And now it has worked. Our auto-scaling group is created. And now if I refresh it, we can see that there's 1 instance that is being created. The desired capacity is 1, the minimum is 1, and the maximum number of instances is 3. So this looks great. I'm going to close this little window. Okay, so now if we look, we can look at all the configuration we set from before. So we can see that the launch configuration is this one. We can see the desired capacity, min capacity, max capacity, the type of health check, etc., etc. But more importantly, we can go to activity history. And so it will try to create instances for us. And so here it says successful, it launched an instance, and sometimes things fail, but it's fine because it's an ASG. So we've launched a new EC2 instance, and it said because the actual capacity was 0, and we wanted 1 instance. So that's great. And now if we go to instances, we can see that our instance has been created, and it turns out that it's healthy. So let's see that it actually got created. If we go to the instances tab in our EC2 management console, we can see that now we have 2 instances, the one we created from before and the one that was created by our ASG directly, and they're both running. Now, if we go to the target group and have a look, we can see that in the targets, we now have 2 instances and they're both healthy. So the really interesting thing is that now if we hit our load balancer, we see that we get hello world from 2 different DNS names. So we can see that it's switching from 141 to 215. So that means that our load balancer is actually spreading the load between our 2 EC2 instances. And that's really awesome. So another thing I can do, obviously, is if I wanted to play a little bit and go to my instances, I could definitely terminate the 1 instance we created from before because we don't need it anymore and it's not attached to an auto-scaling group. And in the auto-scaling group configuration, now we can say, I don't want 1 instance. I would like to have, and I'll edit it, I would like to have 2 instances. And click on save. And basically what this will do is that now our auto-scaling group will try to match this desired capacity. So I'll go and refresh this. And what we should see in the activity history is that in a second, our EC2 instance is not yet in service, but being created. And so if we go to instances and refresh, we can see that now there is an instance right here that is going to be created. So it's running. And so if we go back to our target groups and have a look at what is registered in the health checks and targets, we can see that now we have our instance from before, and the other one is an initial health status. So you can play around and refresh your load balancer. As you can see right now, my load balancer only redirects to 1 specific instance. But if I wait a minute or 2, I should be able to see my 2 instances being in service behind my load balancer. So let's wait a second. We can see that now if I refresh my page, we can see that the instance is changing. So this is great. It's all working. My target groups are healthy. As we can see, we have 2 instances being healthy, and it can take a bit of time to register everything. And if you go back to the auto-scaling group now, what I want to do is to basically edit this and set back my desired capacity at 1, just to make sure that my instances are not overutilized and I don't go over the free tier. So basically now that the instances is equal to one as a desired, but we have 2 instances, this will trigger basically a termination, a scale in. And so if you go to the activity history, it will start to terminate an EC2 instance. And I won't show you what happens, but obviously it will go ahead and scale in. So that's it for autoscaling groups. I hope you enjoyed it. I hope you get a better idea of how they work, and I will see you in the next lecture. Okay, we are getting into EBS volumes. So we've seen that when we terminate our EC2 machines, they basically lose their root volume. And it happens that sometimes AWS will email you and say, we have to terminate our instance because of a hardware fault or whatever. And so basically when these things happen, you will lose your root volume, and this is not good, right? So sometimes you need a way to store your instance data somewhere safe on an external drive so that even if your EC2 instance is being terminated, well, your EBS volume lives by. And so that's the idea behind using EBS volumes. So EBS volume is a network drive that you can attach to your instances while they run, and it allows your instances to persist data. So we've been using them so far, but using root volume. So EBS volumes, what are they? They're network drives, okay? They're not physical drive. So it's a network drive, and your EC2 instance will be linked to the EBS volume using the network. And the network, because it's used, there might be a little bit of latency, but usually not too much. And that means also that as a benefit from it, you can detach the EBS volume from one EC2 instance and attach it to another one very quickly. An EBS volume, when you create it, it will be locked to a certain availability zone, or AZ. And so basically an EBS volume, if you created it in US East 1A, it cannot be attached to US East 1B. Also, that means that to move a volume across, we first need to snapshot it, and we'll see what snapshots are in a second. EBS volumes, at a high level, they have a provision capacity, so you need to say how many gigabytes you want, and IOPS. IOPS are basically IO operations per second. And you get billed for all the provision capacity, okay? So this is something you say in advance how much you want, and Amazon bills you for it, whether or not you use the total size or the total IOPS. You can increase the capacity of the drive over time in gigabytes and IOPS, as we'll see as well in a second. So in an example, if we want to see a diagram, we have US East 1A, and we have 3 EC2 instances. The first one may have a 10 gigabyte EBS volume attached to it. The second one may have 2 EBS volumes attached to it with 100 gigabyte and 50 gigabytes. So as you can see, we can attach multiple EBS volumes to the same instance. And the EC2 instance number 3 doesn't have anything attached to it. Similarly, in US East 1B, we have only one EBS volume attached to our EC2 instance, and it's 50 gigabytes. So as you can see here, the EBS volumes are really tied to a specific availability zone, okay? And that's what I want you to remember. Now, there are different volume types, and the exam doesn't really ask about them, but it's good for you to know at a high level what they are. There is GP2, such as a good SSD drive that has a good balance between price and performance. There is IO1, which is the highest performance SSD volume, and therefore low latency, high throughput workloads, usually databases. They're very, very expensive. Then you're going to have ST1, which is HDD, so it's for frequently accessed, highly throughput intensive workload, so it's a very good fit for big data applications. And SC1, when you want to have big data application as well, but you need to access your data less frequently. EBS volumes will be characterized in terms of size, as we see in gigabyte, the throughput, megabyte per second, and the IOPS, number of IO operations per second. So when in doubt, always consult the AWS documentation. It will have the latest information on all these drives. And so far, we've been only using GP2 volumes. Usually when you create an EC2 instance, this is the volume you're going to use all along. So we can resize EBS volumes. It's something you should know about. It's new. It's out of February 2017. And so that means we can increase the EBS volume for the size, so number of gigabytes, or for the IOPS. Only for the IO1 volume, you can add more IOPS. After resizing an EBS volume, what you need to do is repartition your drive on your EC2 instance, and then your EC2 instance will be able to leverage the full new size of your drive. As I said before, we can snapshot our EBS volumes. So that means that we can back them up using snapshots, and snapshots will actually only take the actual space of the blocks on the volume. So if we have a 100 gigabyte volume and only 5 gigabytes are actually used, when we snapshot that drive, our EBS snapshot will only be 5 gigabytes. So basically the snapshot only takes the space it needs. So what would you use snapshots? Well, you would use snapshots for backups, for example, for ensuring that you can save your data in case of catastrophes, and for volume migration, so you want to resize a volume down, or change a volume type, or encrypt a volume. Those are very good use cases for snapshots. You can also schedule snapshots using some functions, and basically it will allow you to have a nightly backup of your data, which is quite nice in case of catastrophes again. Something that's extremely popular at the exam is called EBS encryption. And so we can create an encrypted EBS volume, and when we encrypt one, we get the following. The data is encrypted at rest, so that means that it's encrypted when it's written to the volume. It's also encrypted in flight between the instance and the volume, and you have nothing to do. As soon as you attach an encrypted EBS volume to an EC2 machine, they will communicate securely with encryption at flight. And all the snapshots you create out of this encrypted EBS volume are also going to be encrypted. All volumes created from the snapshots that are encrypted are also encrypted. So a lot of times saying encrypted, but this is quite a popular topic for the exam. So encrypted EBS volumes are at rest, in flight, snapshots are encrypted, and volumes created from encrypted snapshots are also encrypted. Encryption and decryption are handled transparently for you. You have nothing to do, okay? Your EC2 instance will still see data being unencrypted over time, but just so you know, it's encrypted at rest and in flight. Finally, encryption, as per AWS, has a minimal impact on latency, so you should absolutely use it. And EBS encryption leverages keys from KMS. We haven't seen KMS yet, but you'll hear, anytime you hear encryption, we will hear KMS. And so KMS encryption provides you something called AES 256 for the strength. And if you copy an encrypted snapshot, you can start encrypting that snapshot, and this is how you would encrypt an EBS volume that was first unencrypted from before. So again, just remember the very first part, data at rest is encrypted, and data in flight is encrypted as well when you use encrypted EBS volumes. Finally, there is sometimes a question around EBS versus instance store. So there are some EC2 instances that you can create, and they do not come with a root EBS volume, and they're called instance stores. And so basically that means that the root volume attached to that instance is physical. It's attached to the machine. So what you get out of it is usually a better I/O performance, but then there's a lot of cons out of it. So on termination, the instance store will be lost. You can't resize the instance store, so you can't make it bigger, and backups must be operated by the user. So overall, I would say if you get this, EBS-backed instances should fit most application workloads. Only people who need extremely high performance and have extremely good DevOps engineers can really use an instance store in the AWS cloud. Now, this last brain dump for EBS, things you should know. EBS volumes can only be attached to one instance at a time, obviously. As I said, they're locked at the availability zone level. If you want to migrate a volume across AZ, that first means you have to back it up using a snapshot, and then you recreate it in the other AZ. EBS backups do use I/O, so you shouldn't run them while your application is handling a lot of traffic, otherwise you will impact the performance of your applications. The root EBS volumes of your instances will get lost when you terminate your instances, but this is something you can disable, just so you know. That's it for EBS volumes. This is not a very popular exam subject, but we still need to know about them, so I hope that was helpful, and I will see you in the next lecture.